Okay, so for the first question, we have x and y, which are discrete random variables. They are jointly distributed with the probability function f of x and y defined in the following table. So they've given us a table below that represents the values of x and y. And let me just draw a line here. So it basically gives us the joint probabilities for the values that x and y take. So from this table, we understand that x can take three values, which is -1, 0, and 1. And y can take three values as well, which are the same. So for the first part, they ask us to calculate the probability that x plus y is equal to 1. So we need the sum of both random variables to equal to 1. And this can only happen in two cases. So we need x plus y equals 1. And this can only happen if x, y take on the values. X is 1 or y is 0, and x is 0 and y is 1. So we want the probabilities for these two events. These are given in the table. We have probability that x is equal to 1 and y is equal to 0, given as 1/6. And then we have probability that x is equal to 0 and y is equal to 1, given as 1/9. Yeah. So the probability that x plus y equals 1 is 1/6 plus 1/9. And this just equals to 5/18. For the second part, they ask us to calculate the probability that x is equal to 0. So basically, you can see that this term does not include y. So we will not cater for the values of y. We want all of the possible values of y in which x is also equal to 0. So for part 2, we will want to calculate probability that x is 0, y is -1, plus probability x 0, y is 0. Finally, x 0, y is +1. This turns out to be 1/9 plus 1/. Yeah, okay. So we have probability that x is 0 and y is 0 as 0. We can omit that. This will just be equal to 0 and plus 1/9. This just equals 2/9 for the second part. For the third part, we want probability that x is less than y. So the value that x takes must be less than y. This happens in three cases. If x is -1 and y is 0, plus if x is 0, y is 1, plus x is -1 and y is 1. Yep. So we can once again look at the probabilities in the table. For -1 and 0, we have 1/9. For 0 and 1, we have 1/9 and 10. Lastly, we have 1 over 18. Summing these up together, we get same to the first part, 5 over 18. I hope this is clear. If there's any question you may ask. All right, I think we can move on to the next question. So this is the table is similar to the one in part 1. So I'll give you guys a minute to look at it and try to solve it yourself, and then we'll solve it together. Okay, so we have the same probability distribution, the joint probability distribution as the first question, but now they're asking us for the expected value of x times y. We know that the expected value of x is defined as the sum all x times probability x of x. So analogous to this definition for the joint probability, we have the expected value of x times y, which is equal to the sum of all x, sum of all y, and we have this expression where I'm noting this as f of xy, which is basically same as this for the discrete case. So yeah, all we need to do is sum all the values, all the combinations together. And so we'll start with x is -1 and y is 1. And we have the probability 1 over 18 plus x is -1, y is 0. The associated probability is 1 over 9. And so on. For the rest of the probabilities. And then we have x is 0. So all I'm doing is summing up all of the probabilities associated with the product of x and y, which gives us the expectation by definition. And lastly, we have x is 1 and y is -1. So 9. Yeah. So we sum all of this together, put it in our calculator, and we should get 1/6. Is there any questions you may ask? All right, this is clear. Let's move on to the next question. Take a minute to read it and try to solve it yourself. Or just get an image in your mind and then we can go through it together. All right, so once again, so for the first 3 questions, we're given the same probability distribution, but we're asked for different things. So it covers a variety of topics. For this question, they ask us to find the conditional distribution of y given x is equal to -1 for the table below. And then they ask us to find the conditional expectation of y given x equals -1. So once we have the distribution, it's going to be easier to find the expectation of the conditional distribution. So we're given x is equal to -1. This means it would make our lives easier if we have the probability that x is equal to -1. There's no need to calculate the marginal PMF of x, but we would want to find the probability that x is equal to -1. So let me just decrease the size of this table. So, okay. So we have probability of x is equal to -1. We want all of the values of y in which x is equal to -1. So we have x is -1, y is 0, -1, y is 1, -1, y is -1. This is equal to 1/9 plus 1/18 plus 1/6. And this should be 1/3. All right, so we have probability that x is equal to -1 as 1/3. Now, what do we want? We want the conditional probability function of y given x is equal to -1. Y can take on 3 values only. That's defined already. So let's define the conditional probability function as y given x, y given x equals -1. Sorry. So yeah, we want to find the y can only take on 3 values, so we're expecting 3 probabilities. We want to find the conditional probabilities. So let's take y equals 1. So to find 1, just to clarify, let me add a y as well. Find y equals 1 given x equals -1. We have our, from basic principles, we know that the conditional probability is equal to the intersection divided by the probability of whatever the condition is being based on. So this would just be here, x is -1 and y is 1 divided by probability that x is equal to -1. So we calculated the probability of x equals -1 as 1/3 right over here. And now we just need to find the probability of y equals 1 given x equals -1. So this just becomes for y is 1, it becomes 1/18 divided by 1/3, which is equal to 1/6. So we have one of the probabilities. We have y equals 1 given x equals -1 is 1/6. Now we find the probability that y equals 0 given x equals -1. Once again, this is the intersection. Sorry. The intersection of x equals -1 and y equals 0 divided by the probability of x equals -1. So this out. So sorry, this just equals 1/9 divided by 1/3. So let me just write the final value here. Save some space. This is 1/3. And for the final value, which is y equals -1 given x equals -1. This is equal to -1 intersection of -1. And then this just becomes 1/6 divided by 1/3, which is equal to 1/2. So just for a sanity check, you can try summing up these values, these 3 values, and you should get 1, which makes it a probability distribution. So moving on, now that we have the probability distribution, we want to find the conditional expectation. And we can just do that by, so let me just write the formula. You want the conditional expectation of y given x equals -1. This is sum of all y, where we multiply the product, we find the product of all y's with their associated conditional probabilities. -1. Yeah, so for y is equal to 1, we have 1 times 1 over 6. When y is 0, we don't need to calculate for that. And when y is minus 1, we have the probability of 1 over 2. This just becomes minus 1 over 3. So the expected value of y given x equals minus 1 is minus 1 over 3. Is this clear? If there are any questions you may ask. All right, so let's move on. Take a minute and try to do it yourself. Then we can go through it together. By the way, I understand that in the guest lecture, things were a bit fast-paced, and Sir wants to recap those concepts in his own lectures. So for the quiz, just expect to be tested on continuous probability distributions up to whatever is covered in the homeworks. So homework 4, they are, I think, exponential and uniform, but you should have a look as well. So expect to be tested on that on the quiz on Monday. So for question 4, it says, suppose that 3 balls are chosen without replacement from an urn consisting of 5 white balls and 8 red balls, so that gives us 12 balls in total. That x sub I equal 1 is so let x sub I equal 1 is the ith ball is white, and let equal 0 otherwise. Give the joint probability mass function of x sub 1 and x sub 2. So just to make this clear, x sub 1 is equal to 1 if the first ball we choose is white. And similarly, x sub 1 is equal to 0 if it's red or not white. So they ask us to find the joint probability mass functions of x1 and x2, and then x1 and x2 and x3. Part A, we have x1, which can take 2 values. Similarly, x2 can also take 2 values. So we just need to find the probabilities that x1 equals. We're trying to find the combinations, all the possible combinations of these 2 random variables, so that both of them equal 1. So what does this mean? This means that in both the balls that we choose for the first 2, we have white balls. So the probability that the first choosing is white is just 5 over 13, since there are 13 total balls and 5 white. The Zoom meeting will end in 10 minutes, so just join using the same link. And then we have x2 equals 1, which means that the second ball is also white. So this is 4 over 12. This just becomes 5 over 39. Similarly, if you let x1 equal 1 and x2 equals 0, we get 5 over 13 times 8 over 12, which then becomes 10 over 39. Now we let x1 equal 0 and x2 equal 1. So let's first look at the so both the balls are not white. We get 8 over 13 times 7 over 12, which is equal to 14 over 39. And then we have so the first ball is not red, which is 8 over 13 times the second ball is red. Sorry, first ball is not white, the second ball is white. So 8 over 13 times 5 over 12. Note that we're not looking at the third ball because we're only concerned with the probability distribution of the first two balls. So just give me 1 second. My apologies. So anyway, this just becomes 10 over 39. And just for a check, if you want to verify that this is the correct solution, you can sum up all these probabilities and you will find that they sum up to 1. We follow the same logic for 3 balls. So for part B, I don't think I really need to go over it again, unless anyone wants me to. I don't have a problem, but we have like exponential questions later on, so I want to cover them as well. So I'll attach the solution in the PDF I upload. But for now, it just follows the same logic. So this is based on exponential distribution. Just take a minute to go over it and then we can go through it. Okay, so we're given the number of days that elapse between the beginning of a calendar year and moment a highest driver is involved in an accident to be exponentially distributed. An insurance company expects 30% of highest drivers will be involved in an accident during the first 50 days of a calendar year. So during any of the first 50 days, we have a probability of 30% that the highest drivers will be involved in some sort of accident. We want to calculate the portion of high-risk drivers expected to be involved in an accident during the first 80 days of the calendar year. This is just a different way of saying find the probability that a high-risk driver will be involved in an accident in the first 80 days. So for an exponential distribution, we should keep in mind the PDF. So the PDF of an exponential distribution is lambda e to the power minus lambda times x. Over here, we have one parameter lambda, and we know that the average is equal to 1 over lambda. So this is equal to the mean or the expected value of x. And the variance is equal to 1 over lambda squared. All of this is given in the notes as well. I'm assuming that Dr. Satash uploaded. So do we'll go over them for the CDF, cumulative distribution function. This is just the probability that our random variable will be less than or equal to some value that x takes. For the continuous case, we don't really need the less than or equal to sign. Less than is also fine, since a probability equal to something in a continuous distribution is equal to 0. So for our question, we're given that in the first 50 days, the probability is 0.3 of a highest driver to be involved in an accident. So let's say that these were the definitions. Now let's define t as the number of days that elapsed before a highest driver is involved in an accident. Okay. So we're given probability that t is less than or equal to 50, since it says that it can happen in any of the first 50 days. So, and we have t as the number of days that elapsed before an accident. So makes sense to find the probability of t is less than or equal to 50 that we're given as 0.3. Over in the above section, we define the CDF of the exponential distribution as okay. So we have the CDF of the exponential distribution in the section above. I forgot to define it. So this is just equal to 1 minus, let me just verify it. It should be 1 minus e to the minus lambda x. Yep. Okay. So the probability of t taking a value that is less than or equal to 50, we're given that as 0.3 and 30%. This is just equal to 1 minus e to the minus lambda times 50. Why are we doing this? We don't have the value of lambda, so we can't really calculate the probability of the first 80 days being elapsed before a highest driver is involved in an accident. So to find lambda, we make e to the minus 50 lambda the subject, and we get 0.7. This just implies that lambda. So we take log on both sides and divide by negative 50. We get the following expression, minus 150 times ln of 0.7. Now that we have lambda, we can find, it's pretty easy to find the probability that t is less than or equal to 80. Once again, this is in the form of CDF. So we want 1 minus e to the minus lambda times 80. We have lambda. So this will just turn out to be e to the, so lambda is already negative. So the minus signs cancel. And we get 80 over 50 times ln of 0.7. This is equal to 0.434 that I calculated earlier. So what we just did in this question is we had the cumulative distribution function of an exponential distribution defined as 1 minus e to the minus lambda x. We're given the probability that t is less than or equal to 50. We find lambda, and we just find the probability that t is less than or equal to 80 using the CDF formula by plugging in the values of x and lambda that we found earlier. Are there any questions regarding this solution? Okay, so let's move on to the next question. Just take a minute to go over it. Okay, so for question 6, we're given that buses arrive at a specified stop at 15 minutes interval, starting at 7 a.m. So they'll start arriving at 7 a.m., then they'll arrive at 7:15, then 7:30, and so on. So if a passenger arrives at a stop at a time that is uniformly distributed between 7 and 7:30, find the probability that he waits for less than 5 minutes for a bus. So Note that a uniform random variable from 7 to 7:30 just means that the passenger is equally likely to arrive at any of the time slots. We want specifically the probability that he waits for less than 5 minutes for a bus. When will that happen? So let's just define a random variable first. Let's denote the minutes past 7. That the passenger arrives at a stop. So we know that x is a uniform random variable. X is uniform from 0 to 30. And we want the passenger to wait less than 5 minutes. When can this happen? We know that the bus will arrive at either 7:15 or 7:30. We will not count for the bus arriving at 7 o'clock because the passenger will either arrive on time or will be late for the bus. So in order for him to wait for less than 5 minutes, the person will, so let me just write this. They can either come between 10 and 15 minutes after 7 or between 25 and 30 minutes after 7, because we know that the bus will arrive at 15 minutes after 7. So between 10 and 15 minutes, there's a 5-minute waiting period. Times of the bus are deterministic. They will not arrive at any other time. That's not a random variable. And then we know that another bus is going to arrive at 7:30. So 25 and 30 minutes, either mein mein agar wo passenger aata hai, that would constitute to a waiting period of less than 5 minutes. So we want the probability that the time after 7 is between 10 and 15, or it's between 25 and 30. So this just becomes, for a uniform random variable, if we're looking for, let me just define this. If we're looking for the probability that A is less than X is less than B, or for any continuous random variable for that matter, we know that the PDF of a uniform random variable is, so we have two endpoints. Let this denote A and B. We know that the PDF, sorry for making this a bit messy, you can ask me if there's any confusion, but the PDF is equal to 1 over B minus A. And to find the probabilities, this will be more confusing. Let me just denote this as C and D. To find the probabilities ranging from C and D, all we need to do is to find the integral from C to D of the PDF. Let's just note this as dx. So the uniform random variable won't really have the variable itself in the distribution. So we'll always have a constant term inside the integral. So there's a general form to calculate the probabilities as well. I can't recall the formula right now, but it's probably given in the notes. So to find the probability that x is between 10 and 15, we need the integral from 10 to 15 of, we have a as 0 and b as 30. So b minus a just becomes 30 plus the integral from 25 to 30. It's 1 over 30 dx. Solving these integrals and summing the values up, this gives us 1 over 3. These are pretty simple integrals, so I don't think there's a need to solve them. Are there any questions on this solution regarding the solution? All right, so we can move on to the last question, which is once again on exponential random variable. So how do I know this is exponential? It doesn't really say anywhere, but it says that lambda is equal to 1. So that just means that we know that the PDF of an exponential random variable is lambda times e to the minus lambda x. If lambda is equal to 1, then this just becomes e to the minus x. And in the question, we have f of t. So f of t just becomes e to the minus t. So let's just solve this. We're given the lifetime t in years of an electronic component, which is exponentially distributed, or as it says in the question, it's a continuous random variable with the PDF given by that, e to the minus t. Find the lifetime L, which a typical component is 60% certain to exceed. If 5 components are sold to a manufacturer, find the probability that at least one of them will have a lifetime less than L years. So what do we want? We want the probability that T is greater than L. Remember, in the last exponential question, we defined the probability that x is less than or equal to x, CDF, as 1 minus e to the minus lambda x. So for this is a complement of the CDF. It's also called the survival function. But how will we calculate that? The complement is just 1 minus whatever we're taking the complement of. This is 1 minus t is less than or equal to L, which just becomes e to the minus L. I hope this is clear. So once we subtract the expression of the CDF from 1, we're just left with the exponential term, which becomes e to the minus L for the specific question. Now, what do we want? We want the lifetime, which is noted by t, to exceed some number of years, which makes it 60% certain to exceed. So according to our distribution, let's first denote, equate this with 0.6. So what are we equating with 0.6? We're just equating the probability of t greater than L. So the certainty 60% that the lifetime will exceed some L that we want to find. Through this expression, we find L to be, we take log on both sides, and we find L to be equal to 0.5. 0.51, approximate to two decimal places. This is in years. So L is 0.51 years. We found that. Now they say if 5 components are sold to a manufacturer, find the probability that at least one of them will have a lifetime less than L years. So what do we want? We want the probability. So, yeah, the probability that at least one component has a lifetime less than 0.5 years. 0.51 years. Well, we can say that this is equal to 1 minus the probability that no component has a lifetime less than 0.51 years. So no component has lifetime less than 0.51 years. If no component has lifetime less than 0.51 years, that means all 5 components have a lifetime that is greater than 0.51 years. We know that the probability of so we know the probability of T greater than L is 0.51. This is equal to 0.6. So the probability for all 5 components having a lifetime greater than 0.51 years, assuming that the lifetime of each component is independent, we will have 0.1 minus 0.6 to the 5. Why is it 0.6? Because we calculated above the probability that T exceeds 0.51 for one component to be 0.6. This is just assuming all components are independent. So then we have this probability, which is equal to 0.92. So the probability that at least one component has a lifetime less than L, which is 0.51 years, comes out to be 0.92. Are there any questions? Okay, so that just brings us to the end of the tutorial. Thank you for joining, and best of luck for your quiz on Monday. Bye-bye.